So sometimes we need to improve the capabilities of a model. We can use static or dynamic approaches. If you're getting bad answers from an AI, then you might want to look into some of these options. So what is static versus dynamic? Just as a general computer science principle, static is upfront and non-changing. So this would be fine-tuning. So if your model itself is not working the way you want, you can create a variation of that with fine-tuning to be specialized in some area. So when you're looking at different models out there, you might see some specializations that were built with fine-tuning, and they're built off of some base model. So it'll look something like this, where we create that specialization. It's derived from a base model, and we could, in theory, create multiple specializations. So you might be able to test and figure out which specialization works best. The thing though is that this is done up front, and then you have a new model that you will use for multiple prompts. You're not going to be creating new fine-tuned models every time you make a request. So this is something that you would only want to do if there's enough of a reason to create that specialized model. If you just need to change one or two answers, you can just provide additional context. That's more dynamic. So dynamic here means at runtime, which is a computer science concept, when you're actually executing with the model, so you're using the model, you provide to the model some context that will adjust the model's response. And there's a whole bunch of different things you can do. We'll talk about prompt engineering. This is basically a system to get the best possible responses from an AI model. So when do you do static versus dynamic? If you are wanting to create a new model that you will continually use, and that basically has those behaviors and new things baked into it, that's when you would go the fine-tuning route. You would do all of that up front. You would set your training parameters, create the best possible specialized model, and compare it to the base model, see the changes. That's usually a little bit more advanced. Most of the time, you're going to get what you need as a user by going the dynamic route and providing additional context when you're actually using that model. So a bit more on the dynamic options. We can improve the context. We can provide additional data in a database through RAG, and there are runtime parameters. We'll probably have to do a dedicated video to this topic, but an example of this would be temperature. This can adjust the way the model works at runtime. So you don't actually have to create a new model. You can think of these almost like parameter overrides that will change a little bit of the functionality of the model at runtime. Sometimes those platforms give you the ability to adjust those values, so you might see temperature or top K or top P. So hopefully this lesson has taught you that there are different ways you can configure a model. Some of them are done upfront when we are creating that model, fine-tuning, and then others will allow us to change the behavior at runtime effectively.